Fluorescence-activated cell sorting, or FACS, is a widely used technology for the purification of complex cell population based on specific phenotypes such as size, internal complexity, and specific fluorescence markers. It relies on the combination of flow-cytometry analysis to determine a population of interest and the application of an electric field to isolate the selected cells. In order to perform efficient sorting on single cells or to evaluate protein secretion without having to use damaging chemicals, a method such as cell encapsulation in microbioreactors is required. Discovered a new encapsulation platform for FACS, made in collaboration with Secoya Technologies. This platform allows users to effortlessly generate high volumes of double emulsion for the encapsulation of cells, bacteria, or other biological compounds. In this platform, you will find a microfluidic chip, the red drop, placed in the middle of an optical module that allows users to monitor the production of double emulsions in real time. A set of Fluigent flow controllers enables the generation of stable flows by pressurizing tubes that contains the working solutions of continuous flow, shell phase, and core phase. Pressure and flow rates of the system can be controlled using Fluigent, Fluigent's live flow control software. Manual valving systems allow each solution to be dispatched towards a waste or towards the red drop. Depending on the red drop model, double emulsion with a size varying from 20 micrometer to 90 micrometer can be generated, with a production rate of up to 10 kHz. An additional feature, the injection loop, can be added to the core phase flow path for the injection of small volumes of biological materials. Let's try to encapsulate fluorescence beads in water double emulsions. First, the different phases are loaded in the tubes and the system is switched on. The red drop is then filled with the continuous flow at high pressure. From there, the shell phase is pressurized to start the production of single all-in-water droplets. Once the production is stable, pressure is set to the core phase and the generation of double emulsions begins. With a stable production, a solution of bead is injected into the injection loop using a syringe until it's completely filled. The position of the loop is then switched, and after a few dozen seconds, the beads are encapsulated into the double emulsions, which are then recovered inside a tube and ready to be injected via FACS for sorting and further analysis. Using this double emulsion production platform, users can encapsulate various biological compounds such as cells, bacteria, and yeast. The produced double emulsion can be sorted using FACS technology based on specific phenotypes such as size, internal complexity, or gene expression. Sorted double emulsions can be used for further biological analysis such as sequencing or drug testing. Want to learn more? Visit our website.